Hello and welcome. I'm Çağlayan Arkan, Vice President of Manufacturing and Supply Chain at Microsoft. Today, we are talking about how Microsoft is driving revolutionary research that is helping unlock new empowered experiences for our communities, advance digital transformation at planetary scale for industries, and solve the most challenging issues for our world. With me here today is Ranveer Chandra, Managing Director for Research for Industry and the CTO of Agri-Food at Microsoft and my partner in crime. He also leads the Networking Research Group at Microsoft Research. His research and personal leadership have led to many products and projects, including the notable Azure FarmBeats, which helps farmers gain actionable insights around farm health and output. FarmBeats has been recognized by the United States Department of Agriculture and was selected by Satya Nadella as one of the 10 projects that inspired him in 2017. Ranveer is also leading the White Space Networking project at Microsoft Research, and I could go on and on. Ranveer, welcome. Thank you for being here with me today.
It's my pleasure, Çağlayan. I'm a big fan of the series, The Art of Possible, and thank you for having me on it.
You're very kind. Thank you. So, Ranveer, Microsoft Research for the Industry team, as well as your role, relatively new, right? So it's an important signal for Microsoft's continued investment in industry. Tell us a little bit more about your organization and your charter.
Yeah, this is a new initiative, Çağlayan, as you mentioned, where we are partnering across different groups at Microsoft, led by Microsoft Research and Azure and your team as well. We are working together to invent what is the future of different industries. As you've talked about in this series before, every industry is going through this transformation where data, where AI is changing the way this industry works. And we've done this before with FarmBeats, thinking what is the future of agriculture and bringing new technologies, bringing computer science research, bringing research in agricultural science to the industry to showcase what the future is. And that's what we are trying to do as part of this initiative called Research for Industry. Our vision is to drive thought leadership. Our vision is to show the direction of what's coming next, invent new technologies, and then ship some of those technologies as part of Microsoft products and bring these tools, these inventions to our partners and customers as they re-envision the future of these industries. Now, one question you could ask is, how do you get there? It's huge. How are you going to work across all of these industries, across manufacturing, agriculture, food, energy, supply chain, financial services? The way we are doing it is we are working on 4 key pillars which span all of these industries. The 4 pillars are, the number one is sustainability. It's not about how do we make Microsoft more sustainable, but it is about how do we help our customers meet their sustainability goals.
Make it actionable, right?
Yes, and then for that we need new inventions. We need to think out of the box. We need to work with people in that domain and empower them with the latest in data and AI. So that's pillar number one. The second pillar that we are innovating on is on last mile and edge compute. That is, we need to capture more data. We need to bring in more data to these industries. For that, we need to bring connectivity in different scenarios. Think of space-based communication. Think of private 5G networks. Think of new types of sensing methodologies, last mile drone delivery. How do you make all of that happen? The third pillar is on simulations and AI. Nearly every industry we work with uses simulations. These are physicists, chemists, biologists who are using these science-based simulations. Unfortunately, they take a long time to run. They are very compute heavy and they take a huge amount of time to run. We are inventing techniques using AI in which you can run those simulations much faster. You can start exploring and figuring out the right set of inputs to use for those simulations. Where previously things that would take much, much longer, in one case, we are able to do it 1,500 times faster than what existed. So this is the third pillar. And the fourth pillar is around data, around how do you make sense of unstructured data? I've heard you talk about how only enterprises use only 1% of their data. Well, one of the biggest reasons is a lot of that data is unstructured, semi-structured. How do you make sense of that? How do you share this data, say, across the supply chain? So these are 4 different pillars across which we are innovating. We are doing this work internally at Microsoft. We are working with other companies, their R&D departments, and we are also working with academia to do research in this space.
Amazing. Like this is all music to my ears. One, you start with sustainability and making it actionable, particularly around what we're going to talk about today in terms of food and feeding a world population of 10, 11 people sustainably. It's incredibly important. We talk a lot about cloud, but Microsoft's unique position as far as hybrid and the fact that a lot of stuff starts at the intelligent edge and then move to the cloud. And you meet the customer or the value chains where they are. Data is that layer that brings everyone together and lights up new value chains and new value for all value chains, actually, or supply chains. Amazing stuff. Very exciting.
Yeah.
But I shouldn't say but. And I'm particularly excited about the fact that driving rich research and then bringing research to life through executability and getting it closer to commercialization. So how are you thinking about that? Where are you partnering across the research and industry communities? This is a very new concept, and I'm delighted that it's coming from Microsoft and you as a partner to me.
Yeah, and this is a great question, Cağlayan. I've been at Microsoft Research 17 years, Microsoft 17 years, and typically it takes a long time to get research in the form of product because you have to validate it. You have to go through different technology readiness levels. And we are adopting the same pattern as what NASA does. So they use this thing called technology readiness levels, taking it all the way from starting from an ideation all the way to making it a product, getting it in the hands of customers. So we've defined 9 readiness levels and we take it through that. And one of the questions you asked, which is very important, is, research right now is organized in terms of disciplines like computer science, electrical engineering, agriculture, chemistry. For this next wave of innovation, we need all of us to work together.
To value chains, right?
Yes, exactly. And we need us to collaborate closely with them. This hasn't really happened before, and that's what we are lighting up. We have experience in the past. With FarmBeats, we had to do the same thing. We had to work with the agricultural experts, and we are doing the same thing here. We believe at Microsoft Research we have among the world's best computer scientists, but we are partnering with the scientists in other domains, in chemical engineering, in agriculture engineering, in food engineering, in supply chain operations research. These researchers would be either in academia or they could be in our customer R&D organizations. Our customers, they invest a lot in R&D, but we have computer scientists who can work with their researchers to light up this future of that industry. And that's something we are actively doing, partnering with several academics across Georgia Tech, Stanford, University of Washington, and other places, and also with industries as well. The other thing I wanted to point out, which you asked was, well, how do you commercialize these things? Not all of it will get into products. That's the point of research. A lot of it is risky. A lot of them might not work, might not align with the way Microsoft ships products. So the way we are taking these technologies to products, we are looking at different opportunities. Of course, if this can ship as a Microsoft product, as part of Azure, Dynamics, or anything else, awesome. If not, we are also looking at other ways where we can license some of these technologies to our partners, such as our SIs or ISVs, and get them to use some of these latest technologies. Another thing we are looking at actively is using open source, where there are some components which we actively put out in open source and build an open source community around it. But the key thing behind it, the underlying message is that while we are innovating in these new technologies, we are also looking actively at ways in bringing it to the hands of customers, bringing it in the hands of consumers, working with our partners and customers.
That's all fascinating because I think this is responsible leadership, very thoughtful leadership, as we're all proud of being part of Microsoft at Microsoft. And I will say the implications here are just much broader. So I love the fact that we're bringing everyone along as an ecosystem. Obviously, from research to productization, commercialization. But you and I know for a fact that actually our customers are looking into service-based models. So from products to services, we announced, you should be very excited about this recent announcement with Bayer, right? Transitioning from selling jugs of herbicides to selling weed-free fields as a service. Now it's a mouthful, but it's also a major kind of groundbreaking innovation. So let's let's hear from you in terms of the service-based models and how you are, what's your view on those?
Yeah, no,
evolving?
this is a very interesting transformation that's happening. It started a lot in the software sector. We started selling things as a service, platform as a service, infrastructure as a service, software as a service. Now people are doing more and taking it to different industry services as a service. Like you said, agriculture as a service, precision agriculture as a service. And as more and more of these as a service models happen, which is bound to happen, because as companies look to improve efficiencies, reduce costs, they want to pass on these efficiencies to the consumer. Like, for example, just taking precision agriculture as an example. Until now, companies would sell, say, herbicide to customers. Customers would buy herbicide and apply it. With precision agriculture, you would need much less herbicide because you're applying herbicide only where it is needed. But that requires additional data, additional tools to figure out where is the weeds. And that is where the additional cost that comes, it's hard to package it as a product. Whereas a service model, you can start then enabling new efficiencies like precision agriculture. What that does is it helps reduce costs. It helps be more productive. Farmers can grow more if they can manage weeds better. And it's also better for the environment because you're not putting more herbicide, for example. You're putting herbicide only where it is needed.
Absolutely.
But to drive this transformation of as a service, we need more data. We need more technologies such as IoT. We need edge technologies to bring all of that data in, and new AI, which can light up these insights to really drive this as a service model. Because as a service, you're providing insights to all your customers. And these insights would come from AI. And we are looking at ways to partner with these companies through this transformation. We work very closely together, Chan, your team and my team, where as we work with customers, as they're looking to move towards this as a service model, we could bring them the right tools for data, the right tools for AI, the right tools for simulations to help them make that transformation.
Yeah, what I love about this whole kind of as a service model and how we partner is that creation of these digital feedback loops, right? Because once you're connected to your working environment, so if you're all converging at the farm, for example, going back to precision agriculture, then you're constantly you're looking at that feedback loop of you used herbicides and sustainability as an example, or cost savings. Same goes for water. And then, and then so data, actions, insights, and new data, and new actions and insights, constant measuring and constant improvement and evolving. So a huge theme about the importance of data, and obviously insights that drive them, because insights what will drive the efficiency, the sustainability, and will drive growth. So with that, let's move a little bit to data collaboration, and most notably across the value chain. I love the notion of the value chain, because we know, like, industry is one way to look at things, but when you look at value chains, food is a wonderful example. It's probably, 10, 15 different industries coming together, starting at the farm. Even at the farm, we have like 5 different industries converging, and all the way to retail, across the logistics and packaging and processing, etc. So what can we learn from your research relative to this whole data collaboration across the value chain?
Yeah, and food was an interesting one, which we could start with, where one of the research themes that we have in our group is around the future of food, which is going to be more transparent. You'll be able to know what's happening with your food throughout the supply chain. And as you said, there's so many industries that would benefit from this data that goes through the supply chain. The thing is that there's so many entities involved, and all the data just sits with that entity. Very little is shared across the value chain. At Microsoft Research, we are building new technologies, one, to get more data, to help, say, a trucking company build a connected truck, where you can do pallet level sensing of what's going on, to helping, say, an agriculture company know more about what's happening in the farm. One of the tools, and this is where we are bringing in research, new research technologies, just to tell the audience the kind of research that we do. One idea that we recently built, we haven't talked much until now about it, is called SpaceEye, where the idea is using AI to see through the clouds in satellite imagery. You want to see what's happening in the port of Seattle, in the port of San Diego. Well, right now, if it's cloudy, you really can't see what's happening below it. One of the new techniques we built is using two satellites, a satellite which has radar in it, radio signals go through clouds, they reflect differently from different surfaces, and we use those reflections to then fill in gaps below the clouds. We've come up with a new AI technique called partial observation GANs. You can use it to see farms when it is cloudy, you can use it to see ports, you can use it to see construction sites. Now, going back to the earlier point, we are building these tools for every entity in the supply chain to learn more about what's happening with their customers, with their operations. The next thing we have to do on top of it is to enable them to share the data, because once they share the data, it lights up a lot of new scenarios. Think, for example, traceability for food safety, for example. You want to know when an outbreak happens, what triggered it? Was it a warehouse? Was it a retail store? Was it a restaurant? Was it further upstream? Did it happen in the farm? You want to track it down and then stop or recall the food right away. The other one is around nutrition. You want to know what you're eating, what's the nutrition content of that food. It depends a lot on where it came from, how it was grown, whether it was grass-fed beef or not. So those things matter. Similarly, around sustainability. How was my food grown? How was what I'm wearing? How did that, like the shirt I'm wearing? Did it grow in a farm that was using sustainable practices? You get all of this. You need to share this information across the supply chain if you want to light up these scenarios for the customer. In Microsoft Research, we are developing new techniques. One of the techniques we are building is on making sense of semi-structured data. Can you figure out data models for data that is unstructured or semi-structured? The other thing we are looking at is new ways to enable data sharing. That is, data not just in rest or in transit, but even in use. That is, I could be sharing data with you. You don't see the data, but you can run optimizations on top of this data. And this is something that we're enabling around multi-party compute scenarios. So you can have multiple people where you can do collaborative tasks without actually seeing the data. One of the techniques we've developed is on homomorphic encryption, which does kind of that, where you can perform operations on data on encrypted data. So you won't see my data.
So it's encrypted at compute.
Encrypted at compute. So
Wow.
Not just data at rest, data in transit, but also data in use is encrypted, so people don't have access. And these are new tools. We are essentially taking trust to a different level where we can enable companies to share data with each other, trusting that there is mathematical proofs around this fact that the data won't be leaked. One of the products that we have at Microsoft is Azure Confidential Compute, where with confidential compute, you can rent these VMs, you can rent machines where the data, the only time it is decrypted is in hardware. So no one really has access to the data or in the open. And these are places where we are continuing to push the boundary of enabling data sharing, of lighting up these scenarios that we talked about. For example, in the food case around sustainability, nutrition, and food safety.
I think that thing alone, this homomorphic encryption and encrypting a compute, is $1 trillion value proposition. Because if you can encourage everyone to share their data, then you create a whole new value chain. What we're seeing, and we know this for a fact, but everyone thinks that their data is gold mine, and they will hang on to it, but that is a huge opportunity cost. I like to say, lead with opportunity as opposed to leading with risk, right? So I think that's a huge call to action from us. So we talked about sustainability a lot, and customers are really, really, like, I'm looking at every CEO and top 3 priorities sustainability is going to find its way into, like, regardless of industry, regardless of the size of the company. So how are things changing from your engagements relative to the sustainability goals and our aspiration to make it actionable, bring it to life, and see like tangible results from like water and carbon and all other aspects of sustainability?
Yeah, and this is such an important problem, Çağlayan, and I know you are very passionate about it, and this is something which is one of the most important pillars for our group, where we talk to customers, we look at what the problems are and come up with ways to help them meet their sustainability goals. And we are working across the board with different industries. With the energy industry, we partnered with the Northern Lights, where we are looking at ways to enable carbon capture and storage, being able to capture the carbon as it comes out and push it deep in the ground. That is one way in which we are investing a lot of tech. In my team, we built ways to speed up those tasks, helping these companies reduce their emissions. That's one thing we are working on. We are also working on new ways to make agriculture sustainable as well. We have, for example, with agriculture, the interesting problem is that agriculture is one of the biggest emitters of carbon, they are going to be most affected by climate change as well. That is, farmers, they rely on weather. If the weather becomes unpredictable, the farmers will get impacted the most. The interesting thing is agriculture could be a solution to climate change as well. Because with farms, if the farmers use the right practices, they can take carbon from the air and push it in the ground. Like one of the ways in which I like to dumb down the sustainability discussion, especially to my daughter, is what I tell her is carbon above the ground is bad, below the ground is good. So if you can come up with ways to take carbon from the air and put it in the ground, like for example with plants, they can use photosynthesis to put some of this carbon back in the ground. That is good. So in our group, we are building tools for different industries. Like I talked about agriculture, where we are coming up with ways to, at a very low cost, come up to account for the amount of carbon that is sequestered in soil and do it in an accurate way. One of the things where we are partnering with Professor Ratan Lal in Ohio State University is on using your smartphone to estimate the amount of soil carbon that exists. We've of course partnered with Land O'Lakes, as you know, with Truterra, and one of the new tools we built for soil carbon is a what-if analysis tool. What this does is farmers can use it. We are partnering with Andrew Nelson, who's a farmer in Eastern Washington, where he can then try out different things. What if he plants a different crop? What if he uses a different agricultural practice? How is the amount of carbon going to change? How are his emissions going to change? And bottom line, how is his profitability going to change if he adopts these practices? Because that's the level of visibility we need to create. That's what we are doing in agriculture. We are doing similar things in energy. We are doing similar things in supply chain, where based on what practices you're using, trying to help you come up with ways to reduce your carbon footprint. One of the ways we're doing that is using a multi-agent optimization, again, using data sharing. If everyone in the supply chain can start sharing data, we can use AI to guide each entity to help them reduce their carbon footprint. And we are developing algorithms in our team around that as well.
That's brilliant. This is a lot to do with future, but today there are amazing challenges ahead of us, in front of us, particularly related to the supply chains, right? Yeah. And then today's reality is huge disruption in so many supply chains, from the blockages to labor shortages to raw material shortages, you name it. So, and I know this is a major priority for you as well. So, as an industry, what are we working on? How can we help solve these challenges for our customers and for our kind of ecosystems, Ranveer?
Yeah, and this is an important problem where I know you're thinking a lot about it. Your team is doing some amazing work, and we are partnering closely with your team on inventing new technologies to drive more efficiencies in the supply chain. One of the key things we're looking at is how do you add more visibility in the supply chain. The supply chain is very opaque. Again, goes back to data sharing, but once we can do that, we can enable more visibility throughout the supply chain. One of the tools that we built, by the way, this was done with Purdue University around COVID. During COVID, a lot of meat packing plants were closing down because of outbreaks. And one of the tools that we built was a dashboard using Power BI with Purdue University, where you could click on a commodity and a county within the US, and we would tell you what is the ag worker and food risk for that commodity in that particular county in the US. Like, for example, in Yakima, there was a meat packing plant that was going to close, and we were able to flag it a week before it actually closed, that, hey, there is a high risk that this meat packing plant is going to close. People around it can then take precautionary actions. But we need more visibility in the supply chain. That, I think, is absolutely needed. The other thing we are doing with the supply chain is the multi-agent optimization work I talked about. That is, if different entities, like not just one hop upstream, but even further, suppliers can share data, you can drive a lot more efficiencies. And one of the new results that we had in this space was we modeled it as a game theoretic problem. And then what we showed was that if people share their data, it is going to be beneficial for everyone sharing the data. And for certain tasks, like sustainability was one, pricing was another. If you can share this data, what are the AI algorithms, optimization algorithms that you can build on top of it, and you can help it make sustainable as well. The other things we are working on the supply chain include things like sustainability, which I briefly mentioned, as well as to how do you do route planning, how do you do like less than truckload making sure that all the trucks are packed properly. So those are, again, algorithms that we are building. And the final thing, which is more futuristic that we're looking at, is last mile delivery, using things like drones or ways in which you can really speed up the last mile of delivery, where we are exploring some new ideas. Again, the way we are doing innovation is we are doing mostly the data and AI piece, but working with partners who are building the components to light up some of these scenarios.
And that'll help in a big way with the labor shortages and just people not wanting to work anymore, and moving out of the labor force. So it is very, very impressive to see your work, to hear from you directly. I'm listening to you. I'm kind of thinking technology meet sustainability, technology meet food safety, food accessibility, and research meet customer or executability. That is all fascinating. Couldn't be more proud to be partnering with you. What's the last call to action? I always like to I'm action biased as you know me. Is there a call to action for our viewers, Ranveer?
Yeah, and the key thing here, Çağlayan, is this is not typical research where we are not just publishing papers. We are passionate about making things happen, bound to reality. And towards that, we want to partner. We are not the domain experts. We build tools, and we love to partner. We partner with academics, we partner with R&D organizations of companies, and we are looking to learn more. This is not our domain. I'm a computer scientist. All my team is mostly computer scientists. But we believe we can work with people with other expertise. We can work with the chemical engineers, the scientists and physicists, the mathematicians, the biologists. And that's something we are starting to do and we want to do more of. So think of us, this is a call to action for many people who are listening on this call and might not be computer scientists. They are in different industries. Think of us as your computer science arm, people who will innovate, bring the best in data, best in AI to your biologists, to your chemists, to your operations research folks, so that you can get the benefits of the latest that is happening. This can help you future-proof your operations, prevent you from disruption, and also help you drive efficiencies, including sustainability, to new levels. So we're really excited about partnering with people. So that is the main call to action.
I kind of take it personal too. You want my customers and you want my partners to be at the table working with you and your ecosystem from a science and technology standpoint. And I think we can do a ton together.
Yes.
I couldn't be more excited. Thank you, Ranveer, so much for being with me today. And thank you all so much for listening in and dialing in today.
Thank you, Çağlayan.